Tonight, we are going to talk about something that is going to completely reshape how you think about size, about distance, about everything you thought you knew about what it means for something to be big. We are going to explore the largest object ever discovered in the universe, a structure so unfathomably massive that it makes entire galaxies look like floating specks of dust. I must warn you right now, by the time this terrifying journey concludes, you are going to look at the night sky differently. You are going to understand a concept of scale that most people never even try to comprehend. The stars you see outside your window will no longer look like comforting little lights, but rather distant, violently burning beacons in an ocean of absolute, terrifying darkness. Hello, and welcome to This Is Space. I am Christopher, your guide through the infinite dark. If you enjoy these deep atmospheric explorations into the unknown cosmos, please consider subscribing to the channel and leaving a comment below. Your support allows us to keep venturing further into the deep mysteries of the universe, peeling back the layers of reality one by one. Let us begin with something completely familiar to you. Think about your house or the apartment where you live. The average house, perhaps 2,500 square feet, that is a space you can comfortably walk across in about 30 seconds. You know every single corner of it. You know the exact sound the floorboards make when you step on them, the way the light filters through the windows in the late afternoon, the exact distance from your bed to the door. This is a scale that makes perfect sense to your human brain, because you experience it every single day. Your ancient brain evolved on the flat plains of a small rocky planet to intimately understand spaces exactly like this. These are spaces you can see with your own eyes, spaces you can physically walk through and measure with your own human steps. A football field is 360 feet long. You could walk from one end to the other in maybe 2 minutes, without breaking a sweat or even breathing heavily. A mile is 5,280 feet, which is roughly 17.5 football fields laid end to end. Most healthy people can walk a single mile in about 15 to 20 minutes. These are distances that feel substantial, but they are entirely achievable by a human being travelling entirely on foot. For thousands of years, this was the absolute limit of human comprehension. The world was only as large as the distance you could walk in a lifetime. The distance from New York to Los Angeles is about 2,800 miles. That is a 5-hour flight in a commercial airplane, moving near the speed of sound, or about 40 hours of driving, if you somehow never stopped to rest, eat, or sleep. The circumference of planet Earth at the equator is about 24,901 miles. If you could somehow pave a perfectly smooth, straight road around the entire planet and drive around it without ever stopping, travelling at highway speeds of 65 miles per hour, it would take you about 383 hours, which is almost exactly 16 days of continuous, exhausting driving. To a human being, the Earth feels incredibly massive. It feels like an entire universe of its own, filled with vast, terrifying oceans, towering mountain ranges that pierce the clouds, and endless deserts of burning sand. When ancient sailors ventured into the open ocean, they felt they were crossing an endless void. But here is the profound, unsettling reality that modern astronomy has forced us to accept. Compared to the scale of our local solar system, Earth is entirely tiny. It is a microscopic speck of blue and green dust caught in a single beam of blinding sunlight, and compared to the scale of the galaxy, the entire solar system is practically invisible, a mere atom in a vast cosmic ocean. We are about to climb a terrifying ladder of cosmic scales, where each rung makes the previous one look absolutely insignificant. The Moon, our closest celestial neighbour and our constant companion in the dark, is about 238,855 miles from Earth. When the Apollo astronauts traveled to the moon in the late 1960s and early 1970s, they were going farther than any human had ever gone before in the entire hundreds of thousands of years of the history of our species. The journey took about 3 days at mind, bending speeds of roughly 24,000 miles per hour. The fastest you have probably ever to airplane, cruising comfortably at maybe 500 miles per hour. The Apollo spacecraft were moving nearly 50 times faster than that airplane, tearing violently through the absolute vacuum of space. And it still took 3 whole days of endless blackness, isolation, and silence to reach the closest possible object to our home planet. When they arrived, they found a dead, silent world with no wind, no air, and no life. The footprints they left in the grey dust will remain there for millions of years, perfectly preserved because there is absolutely nothing to wash them away. The distance to our local star, the burning centre of our system that provides all the energy for life on Earth, puts all of this into even more terrifying perspective. Our star is about 93 million miles from Earth. If you could somehow build a magical, floating bridge through the vacuum of space and drive a car there at a highway speed of 65 miles per hour, completely non-stop, it would take you about 163 years. You would die of old age long before reaching halfway. You would have to pass the driving duties to your children, who would pass it to their children, and somewhere around your great-great-great-grandchildren, the car might finally arrive at the violently burning, chaotic surface of the star. Light travels at an absolute, unbreakable speed limit of about 186,282 miles per second. This is the ultimate speed limit of the entire physical universe. Nothing carrying information or mass can ever move faster. Every single second, light covers that immense, unimaginable distance. When you flip a switch in your room, the light from the bulb reaches your eyes essentially instantly because the distance is so short. Your brain perceives it as an immediate event, but when you look at our star in the deep blue sky, you are not seeing it exactly as it is right now. You are seeing a ghost. You are seeing ancient light that left its boiling, turbulent surface about 8 minutes and 20 seconds ago. If our star were to suddenly vanish, explode, or wink out of existence this exact second, we would not know about it for over 8 minutes. We would continue to walk around in the warm sunlight, laughing, working, and living, completely oblivious to the terrifying fact that our cosmic doom had already occurred and the darkness was rushing toward us at the speed of light. Because of these truly enormous brain-breaking distances, astronomers use a standard measurement called the light year. Despite having the word year in it, a light year is not a measure of time passing. It is a measure of vast, terrifying physical distance. It is the absolute distance that a single photon of light travels in one entire year, moving unimpeded through the cold vacuum of space. If we do the math, light travels 186,282 miles every second. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 365 days in a year. If we multiply all of these massive numbers together, we get approximately 5.88 trillion miles. That is just one single light year, a single step in the cosmic dark. The nearest star to our solar system, other than our own star, is called Proxima Centauri. It is a small, dim, violently active, red dwarf star located about 4 light years away. That means the faint, reddish light you see from Proxima Centauri through a powerful telescope tonight actually left that burning sphere over 4 years ago. It has been travelling silently through the absolute darkness of empty space, dodging microscopic cosmic dust and rogue planetary bodies for more than 4 years, covering nearly 25 trillion miles just to finally strike the curved glass lens of your telescope tonight. Within about 16 light-years of our solar system, there are approximately 50 known stellar systems. This spherical region of local space, about 32 light-years across from absolute edge to edge, is our immediate local stellar neighbourhood. In cosmic terms, this entire neighbourhood, containing dozens of suns and hundreds of planets, is smaller than a single grain of sand resting quietly on an endless planetary beach. The Milky Way galaxy, our magnificent, swirling and terrifying home galaxy, is roughly 100,000 light-years across. Just pause for a moment and truly try to imagine the sheer weight of that number. A beam of light, moving at the absolute maximum speed the universe allows, 186,282 miles every single second, would take 100,000 human years just to cross from one side of our galactic home to the other. If human beings started a journey across the galaxy right now travelling at the speed of light, all of human history would repeat itself 10 times over before they even reached the other side. The galaxy is about 23,500 times wider than the distance to our nearest stellar neighbour. Our galaxy is a massive, swirling disk of gas, dust and stars, containing somewhere between 100 billion and 400 billion burning stars. Each one of those stars is a massive nuclear furnace, a giant ball of compressed hydrogen undergoing violent, chaotic nuclear fusion in its core, converting mass directly into blinding energy. And practically every single one of those hundreds of billions of stars is now mathematically believed to have its own complex system of planets, moons, and asteroids orbiting blindly around it in the dark. That means there are potentially trillions of planets just within our single, isolated galaxy, billions of which might be rocky worlds existing in the habitable zone, capable of holding liquid oceans of water. Our solar system is located about 26,000 light-years from the very centre of the Milky Way. We reside in one of the quiet, dusty, relatively empty spiral arms known as the Orion Spur, far away from the chaotic violence and blinding radiation of the galactic core. At the very centre of our galaxy lies a sleeping monster, a supermassive black hole called Sagittarius A star, which possesses the mass of 4 million of our suns, completely crushed into a single, infinitely dense point in space. When you look up at the night sky on a clear, perfectly dark night, far away from city lights, and see that faint, milky band of light stretching across the darkness, you are seeing the flat, majestic disk of our galaxy from the inside out, viewed edge-on. You are looking through the thickest part of the disk. You are seeing hundreds of billions of stars so impossibly distant that their individual points of light blur together into one continuous, ghostly glow that looks like spilled milk across the heavens. The star at the centre of our solar system orbits the massive centre of the Milky Way at a mind-bending speed of about 515,000 miles per hour. We are currently hurtling through the vacuum of interstellar space at this unimaginable velocity, dragging the Earth, and all the other planets along with it. But the galaxy is so vast, so unfathomably huge, that even at this extreme, terrifying speed, it takes our solar system about 225 to 250 million years to complete a single grand orbit around the galactic centre. The last time our solar system was in its exact current position in the galaxy, dinosaurs had not even evolved yet. The Earth was in the middle of the Triassic period, a completely alien world, dominated by strange, ancient, armoured reptiles that have been dead and turned to stone for eons. Since that ancient time, the dinosaurs evolved into massive ground-shaking giants, dominated the entire planet for over 160 million years, and were violently wiped out by a catastrophic asteroid impact that darkened the sky, poisoned the oceans, and burned the forests. Small, terrified mammals timidly took over the empty, smoking landscapes. Primates eventually evolved in the dense canopies of new forests. Humans finally appeared, learned to strike flint, to control fire, built grand civilizations of stone and steel, invented modern technology, launched robotic probes into the deep dark, and finally looked up at the stars with true scientific understanding. All of human history, every single war ever fought, every triumph of art, every life ever lived, every tear ever shed, has happened in a tiny microscopic fraction of a cosmic second, and we have only just now completed one single lap around the galactic core. Now you must realize that the Milky Way is not alone in the dark. It is not an isolated island floating in a pure void. The Milky Way is part of a small, gravitationally bound collection of neighboring galaxies called the Local Group. The Local Group contains more than 80 known galaxies, mostly small, irregularly shaped dwarf galaxies that orbit the larger ones like buzzing, glowing insects orbiting a street lamp. The three largest members of this cosmic group are the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. The Andromeda Galaxy is our massive, threatening galactic neighbour. It is about 2.537 million light-years away. When you look at Andromeda in the night sky, and you can actually see it with your naked eye as a tiny fuzzy smudge of faint light, if you know exactly where to look on a completely dark night, you are seeing ancient light that left that giant spiral over 2.5 million years ago. When that light began its long journey toward your eye, our earliest human ancestors were just beginning to awkwardly walk upright on the dusty plains of Africa. They had not even evolved large brains yet. Everything you know about human civilization, every written word, every spoken language, has happened while that single beam of light was silently travelling through the deep, empty vacuum of intergalactic space toward you. And here is a truly terrifying fact about Andromeda. It is not just sitting there peacefully. It is moving directly toward the Milky Way at about 250,000 miles per hour. It is on a direct collision course. In about 4 billion years, these two massive island universes will violently collide in the dark. The delicate, beautiful spiral arms of both galaxies will be completely, violently torn apart by the overwhelming force of gravity. Massive clouds of gas and dust will smash together at millions of miles per hour, igniting massive, blinding waves of new star formation. The supermassive black holes at the center of each galaxy will eventually spiral toward each other through the chaos and merge, sending massive, invisible ripples of gravity tearing through the very fabric of space and time itself. Eventually, billions of years after the collision first begins, the two galaxies will settle into one massive, featureless, glowing elliptical galaxy, commonly referred to as Milkomeda. The night sky of Earth, if the planet somehow still exists and has not been swallowed by our dying sun, will be permanently changed, ablaze with the chaotic, blinding light of 1 trillion rearranged stars. The Local Group is about 10 million light-years across. That is 100 times the diameter of the entire Milky Way. And yet, in the grand, sweeping scheme of things, the Local Group is a tiny, entirely insignificant structure. The Local Group is part of a much larger, more terrifying structure called the Virgo supercluster. A supercluster is a massive, sprawling group of galaxy clusters and galaxy groups all permanently bound together by the relentless, invisible force of gravity. The Virgo supercluster contains at least 100 distinct galaxy groups and massive clusters, including our own tiny Local Group. It is about 110 million light-years across. In the year 2014, astronomers fundamentally redefined our entire cosmic address by discovering that the Virgo supercluster is just one small lobe, just an insignificant glowing branch of an even insignificant glowing branch, more terrifyingly massive supercluster called Laniakea. The beautiful, haunting name comes from ancient Hawaiian words meaning immense heaven. Laniakea contains about 100,000 massive galaxies and stretches an unbelievable 520 million light-years across the pure dark. To put that completely alien scale into perspective, if the entire Milky Way galaxy were shrunk down to the size of a small coin sitting in your hand, Laniakea would be about the size of the entire continental United States of America. Laniakea is defined not just by the sheer, staggering number of burning galaxies it contains, but by how those galaxies actually physically move through the deep void. All the galaxies in Laniakea, including our own Milky Way and the approaching Andromeda, are flowing together like a slow, unstoppable cosmic river toward a mysterious, invisible region of space called the Great Attractor. This is a terrifying, massive gravitational anomaly located about 250 million light-years away in the general direction of the Centaurus constellation. We cannot see exactly what the Great Attractor is with our optical telescopes because it lies directly in a region of the sky known as the Zone of Avoidance. This is a region completely obscured by the incredibly thick, dense bands of dust, gas, and stars of our own Milky Way galaxy. We are basically trying to look out the window. But the glass is covered in thick mud, but by measuring the movements of thousands of galaxies using radio and infrared astronomy, which can pierce through the dust, we know that whatever is hiding back there in the dark possesses the gravitational mass of tens of thousands of entire galaxies. And it is relentlessly, silently pulling us and absolutely everything around us in a sphere of hundreds of millions of light-years toward its unseen centre. Now, you might naturally think that Laniakea, with its 520 million light-year diameter and its 100,000 screaming galaxies, would certainly be among the absolute largest structures in the entire physical universe. But it is not even close. As we drift even deeper into the hidden structure of the universe, please take a moment to subscribe to This is Space, and leave a comment sharing your deep thoughts on this gargantuan discovery. Are we merely microscopic, oblivious inhabitants of a cosmic giant? What terrifying concentration trace of mass do you think lies hidden within the Great Attractor? Let us know your thoughts below. This terrifying realization brings us to the fundamental, absolute architecture of the cosmos itself. The universe is not evenly distributed. Galaxies are not scattered randomly through empty space, like confetti thrown carelessly into the air, or grains of sand scattered blindly on a wooden floor. Instead, they are highly organized into an incredibly complex, interconnected, web-like structure that scientists aptly call the cosmic web. I want you to close your eyes and try to think of a three-dimensional spiderweb stretching endlessly across the entire observable universe, woven in the absolute dark by the hand of gravity. The shimmering, glowing strands of this vast web are called cosmic filaments, and they are made entirely of billions of galaxies, massive galaxy clusters, rivers of boiling hot intergalactic gas, and unimaginably dense strings of invisible dark matter. Where these cosmic filaments violently intersect, where the thickest threads of the web cross each other, you find incredibly massive galaxy clusters containing thousands upon thousands of violently active galaxies, all smashing together in a chaotic dance. And between the glowing filaments, between the threads of the cosmic web, are enormous, terrifyingly empty regions called cosmic voids, where almost absolutely nothing exists. These voids are spherical bubbles of pure darkness hundreds of millions of light-years across, containing only a few lost, lonely galaxies drifting in the absolute quiet. This cosmic web structure emerged from tiny, microscopic quantum variations in the density of matter in the very early universe, just fractions of a second after the Big Bang. Matter was not perfectly, mathematically evenly distributed when the universe cooled down from its initial state of infinite heat. Some microscopic regions were ever so slightly denser than others. maybe by just one single part in 100,000. It was a nearly perfect, smooth, glowing soup of hot plasma. But over billions of years, the cold, patient, and completely relentless hand of gravity amplified these tiny, microscopic differences. Denser regions steadily, slowly pulled in more matter from their surrounding areas. Because they had more matter, their gravity increased, making them denser still, and allowing them to pull in even more matter in an unstoppable runaway process. Less dense regions became emptier and emptier as their matter was slowly, inevitably dragged toward the denser, heavier areas. The cosmic web we see with our telescopes today is the magnificent, violent, and beautiful product of 13.8 billion years of slow, grinding gravitational evolution. Dark matter, a mysterious, invisible, and completely alien substance, which makes up about 27% of the total mass energy of the universe, created the massive, invisible scaffolding on which all visible matter currently hangs. Dark matter does not interact with light at all. It does not reflect it, emit it, or block it. But its immense gravity dictates the entire physical shape of the cosmos. Dark energy, a completely different and even more terrifyingly mysterious phenomenon, making up about 68% of the universe, is aggressively driving the acceleration of cosmic expansion, acting as a repulsive force, trying to tear the web apart from the inside out. Ordinary matter, the stuff made of protons, neutrons, and electrons, the physical material that makes up every single burning star, every rocky planet, every towering mountain, every drop of water, and every human being that has ever lived or died, accounts for only about a pathetic 5% of the entire universe. The complex, invisible, silent interplay between these unseen, dark components shaped the glowing cosmic web into what we boldly observe with our telescopes today. Galaxy filaments are among the absolute largest known structures in the entire universe. A single filament can be hundreds of millions of light years long, containing thousands of individual galaxies strung out like glowing, burning beads on a massive cosmic necklace. But even these massive, glowing filaments are not the largest structures we have found hidden in the deep dark. The Great Walls came next in our slowly evolving, humbling understanding of cosmic architecture. The first Great Wall was discovered in the year 1989 by brilliant American astronomers Margaret Geller and John Huchra. They were painstakingly, manually mapping the three-dimensional positions of thousands of distant galaxies in a thin pie-shaped slice of the deep sky. What they plotted on their computers completely shocked them and forever changed the field of cosmology. Instead of a random, even distribution of galaxies, they saw a massive, solid, continuous sheet of galaxies stretching entirely across their entire survey area. This massive structure, which they called the CFA2 Great Wall, was about 500 million light-years long, 300 million light-years wide, and about 15 million light-years thick. It looked like a literal, physical wall of light spanning the darkness, holding back the void. But the CFA2 Great Wall was just the very beginning of the revelations. As astronomers mapped more and more of the distant, ancient universe, building massive three-dimensional maps of millions of galaxies, they kept finding bigger, longer, and more massive structures. In the year 2003, astronomers discovered the Sloan Great Wall. The Sloan Great Wall is approximately 1.37 billion light-years long. Light itself, moving at its absolute unbreakable maximum speed, would take 1.37 billion human years just to travel from one end of this massive wall to the other. The Saraswati supercluster, discovered by a team of researchers in 2017, is about 652 million light-years across and contains about 400 massive glowing galaxies, arranged in a giant, dense wall structure. It is located about 4 billion light-years away from us, meaning we see it exactly as it looked 4 billion years ago, when our own solar system was just a swirling cloud of dust and gas. The South Pole Wall, discovered in 2020, is a massive curving filament of galaxies stretching at least 1.4 billion light-years across the southern sky. It sits silently behind the plane of the Milky Way in a region of the sky called the Zone of Avoidance, where incredibly thick gas and dust from our own galaxy completely block our view in visible light, requiring astronomers to cleverly use advanced radio and infrared telescopes to peer through the galactic fog and see the monsters hiding in the dark. For years, astronomers furiously debated which massive structure held the absolute undisputed record for the largest object in existence. The Hercules Corona Borealis Great Wall, discovered in 2013 through the detection of incredibly violent gamma-ray bursts, was long considered a serious contender for the crown. It appeared to span up to an incredible, mind-numbing 10 billion light-years across, which is a significant fraction of the entire observable universe. However, its true physical status has remained deeply controversial, with many skeptical scientists arguing it might just be a statistical illusion or a series of smaller, completely unrelated structures lining up perfectly from our specific point of view on Earth. But in early 2025, astronomers made a shocking, undeniable discovery that finally settled the fierce, ongoing debate about what holds the true record for the largest confirmed physically coherent structure in the observable universe. They found Quipu. Quipu has an estimated staggering mass of about 200 quadrillion times the mass of our star. Written out, that is 200 quadrillion solar masses. Just to attempt to understand that number, if you tried to count to 200 quadrillion, counting one number per single second without ever stopping to sleep, eat, or breathe, it would take you about 6.3 billion years. Planet Earth would be completely uninhabitable, the oceans boiled away and swallowed by the expanding red giant phase of our dying sun, long before you even came close to finishing counting to that number. The beautiful name Quipu comes from the ancient Incan recording system that used deeply complex, coloured and knotted chords to intricately store vital information, mathematics, taxes and history. The brilliant astronomers who discovered this structure chose this ancient human name because the cosmic structure deeply resembles a complex network of interconnected threads, with massive, densely glowing galaxy clusters forming the heavy knots along the massive cosmic cords. It is a highly fitting, poetic name for something so physically intricate and terrifyingly vast. What makes Quipu particularly significant in the realm of modern astrophysics is that it is a confirmed gravitationally coherent structure. It is not an illusion of perspective. Quipu was definitively detected through high-energy X-ray emissions originating from the incredibly hot boiling gas that completely pervades galaxy clusters. This intra-cluster gas, heated to tens of millions of degrees by the violent gravitational collapse that originally formed the massive clusters, emits powerful, glowing X-rays that we can clearly detect from Earth using specialized space telescopes orbiting high above the atmosphere like Chandra and XMM Newton. The glowing, mapped pattern of these X-ray emissions perfectly reveals the physical, glowing bridges and connections between the far-flung clusters, confirming beyond a shadow of a doubt that they are all physically part of a single enormous, interconnected structure, rather than just an accidental alignment of unrelated objects drifting in the deep sky. The 68 distinct, massive galaxy clusters that make up the heavy knots of Quipu are arranged perfectly along massive, invisible filaments of dark matter that stretch across the dark void between them. They are permanently connected by glowing bridges of boiling hot gas and gravitationally bound into one single, terrifyingly large system. Each of these 68 individual clusters is itself a massive structure containing hundreds or thousands of large spiral and elliptical galaxies, thousands of dwarf galaxies, and trillions upon trillions of individual, violently burning stars. Together, they form a single coherent entity that is almost entirely too large for the human mind to ever truly comprehend. The discovery of Quipu, seriously, fundamentally challenges our entire foundational understanding of how the universe evolved. According to standard cosmological models, which scientists have trusted and relied upon for decades, structures this incredibly large should not be able to physically form in the limited time the universe has existed since the Big Bang. Gravity simply has not had enough time to pull objects across such vast distances. The universe is supposed to be homogeneous and isotropic at large scales. What that scientific term means is that when you zoom out far enough, taking a massive slice of the cosmos, the universe should look exactly the same in every single direction. It should look like a smooth, even, boring fog of matter. Everything should average out to a uniform smoothness. This fundamental principle, called the cosmological principle, has been a central, unshakable cornerstone of our understanding of the universe for nearly a century. Quipu appears to push violently, aggressively against this theoretical limit, completely breaking the rules of cosmic structure formation. It is so impossibly large that explaining how it formed within the relatively short 13.8 billion year history of the universe requires very careful, entirely new physical analysis. Did gravity work differently in the early hot universe? Did dark matter collapse much faster than we originally predicted? Are there exotic particles we have not yet discovered driving this massive clumping? The honest, humbling answer is that we do not fully know yet. Quipu is a dark mystery, a massive, glowing challenge to our scientific understanding, and a stark, beautiful reminder that the universe is far larger, far more complex, and infinitely stranger than we ever imagined in our wildest theoretical physics. The galaxy clusters that make up the dense knots of Quipu deserve much closer, careful attention, because deeply understanding these massive components helps us truly appreciate the terrifying whole structure. Galaxy clusters are the absolute largest gravitationally bound structures in the universe. They are the true behemoths, the massive leviathans of the cosmos, unlike the loose filaments and great walls, which are basically just loose, temporary associations of galaxies, drifting slowly along the cosmic web like sea foam. On an ocean wave, galaxy clusters are dense, incredibly violent concentrations of galaxies permanently locked together by intense, inescapable gravity. The galaxies within a cluster frantically, chaotic orbit a common center of mass, moving at millions of miles per hour, permanently trapped by the massive, inescapable gravitational pull of the entire cluster. A typical galaxy cluster contains hundreds to thousands of swirling galaxies, plus vast, unseen amounts of boiling hot intergalactic gas and enormous invisible halos of dark matter. The seemingly empty space between galaxies in a cluster is not actually empty at all. It is completely filled with a dense plasma gas that can easily reach temperatures of 100 million degrees or more. It is so hot, so incredibly energetic, that it aggressively emits powerful X-rays that light up the dark spectrum. This incredibly hot gas actually contains more absolute physical mass than all the glowing visible galaxies in the entire cluster combined. The galaxies you see in telescope images are just the tiny tip of the cosmic iceberg, and the invisible dark matter contains even more mass than the hot gas, typically about 5 to 6 times as much, holding the entire chaotic structure together like invisible glue. The massive clusters inside Quipu are intimately connected by thick, invisible filaments of dark matter and hot gas, forming an unbreakable, heavy network that spans 1.4 billion light-years from absolute end to end. The profound gravitational influence of each individual cluster extends far beyond its visible, glowing boundaries, reaching out through the dark millions of light years to interact with neighbouring clusters, altering their trajectories and aggressively maintaining the overall structural integrity of the whole Quipu system. When these massive galaxy clusters collide with each other, which inevitably happens when the pulling strands of the cosmic web draw them together over slow eons, the explosive results are among the most energetic, violent and cataclysmic events in the entire universe since the Big Bang itself. It is a terrifying clash of cosmic titans. The galaxies themselves rarely hit each other directly during these massive collisions, because the vast, empty spaces between individual galaxies are so enormous that they basically pass right through each other like ghosts passing in a fog. But the boiling hot gas that completely fills each cluster does collide head-on. This creates massive intergalactic shock waves that heat the already boiling gas to even higher, completely unimaginable temperatures, aggressively stripping galaxies of their cold star-forming material and creating chaotic, twisting turbulence on a massive scale of millions of light years. These cosmic cluster mergers are not quick, instantaneous events. They are agonizingly slow. They can take billions of years to fully complete, during which time the clusters slowly, violently merge into a single, even more massive, glowing structure. The supermassive black holes at the center of their largest galaxies will eventually find each other through the chaos and merge in a terrifying burst of gravitational waves that literally warps the fabric of space and time. Within the vast, deep expanse of Quipu right now, some clusters may currently be in the slow, agonizing process of merging, completely tearing each other apart. Others may have finished merging billions of years ago, settling into a quiet, massive, spherical halo of dark matter and dead red galaxies that can no longer form new stars. Still others may be slowly, inevitably approaching each other in the dark, caught in a permanent gravitational dance, absolutely destined to violently collide in the distant, unseen future. The structure is deeply dynamic, heavily evolving, and constantly changing its massive shape and composition over deep, slow cosmic timescales. As we completely explore the violent physical reality of galaxy clusters, remember to subscribe too. This is space. What would it actually look like to witness two massive galaxy clusters colliding from a safe, distant vantage point? Let your imagination run wild in the comments section below. Now, we must turn our attention completely away from the light and look directly at the absolute darkness. We must look at the terrifying voids between structures like Quipu, which are fascinating, deeply isolating, and profoundly terrifying in their own right. Cosmic voids are the absolute least dense regions of the entire universe. They are the empty, silent rooms in the massive cosmic mansion. They are not completely, mathematically empty, because a true, perfect vacuum does not exist in nature. Quantum mechanics dictates that space is always boiling with virtual particles, and even the emptiest voids contain some tiny, microscopic amount of matter, perhaps a thin scattering of lonely, isolated dwarf galaxies. Extremely thin, cold clouds of invisible primordial gas left over from the Big Bang, and faint, wispy dark matter halos. But compared to the glowing filaments and the bustling violent clusters, voids are practically perfect vacuums of cold death. The average density in a deep void might be 1/10 or even 1/20th of the average density of the rest of the universe. The largest known void in our currently mapped universe, the giant void or Boots void, is a terrifying spherical region about 330 million light-years across. It is a completely silent ocean of absolute nothingness. Within this enormous silent spherical region, only about 60 lonely galaxies have ever been found by our most powerful telescopes. That sounds like a lot of galaxies until you realize the scale. A similarly sized volume elsewhere in the dense, webbed parts of the universe might easily contain 2,000 massive galaxies or more. The Boots void is so unbelievably empty that if the Milky Way galaxy had been placed precisely in the exact center of it, we would not have even known other galaxies existed until the invention of powerful deep space telescopes in the 1960s. We would have thought our galaxy was the entire universe. What would it actually be like to exist inside a void? Imagine an intelligent, curious civilization slowly evolving on a lonely rocky planet, orbiting a solitary star inside the dead center of the Boots void. When they looked up at their night sky after inventing telescopes, they would see almost absolutely nothing but the stars of their own single galaxy. Their own galaxy would be visible, a faint, beautiful band of stars stretching across the absolute darkness. But the distant, comforting glow of other neighbouring galaxies would be almost impossible to detect without incredibly advanced technology. Their cosmic horizon would feel much closer, much more completely confining, isolating, and utterly claustrophobic. They might naturally, logically conclude that their lonely galaxy was entirely alone in the whole universe, an isolated, accidental island of matter floating forever in an infinite, dead, and completely uncaring emptiness. The profound psychological impact of realizing you are utterly alone in a spherical void of 300 million light-years would be staggering to any intelligent species. The dark, empty voids and the glowing, dense filaments are two sides of the exact same cosmic coin. You cannot physically have one without the other. The matter had to be violently pulled from the voids by gravity over billions of years to build the massive glowing walls and clusters. Picture in your mind what it would be like to actually travel across the entire length of Quipu. You board an impossible spacecraft, a magnificent vessel of human imagination that can magically accelerate instantly to the exact speed of light, 186,000 miles per second. You position yourself at one edge of Quipu and begin your epic, impossibly long crossing. The structure stretches endlessly before you. 1.4 billion light-years of dense galaxy clusters, glowing gas filaments, boiling hot plasma, and invisible dark matter structures. For the first million years of your journey at light speed, you travel through relatively sparse, quiet regions. Quipu is not uniformly dense at all. It has massive structure within structure, completely empty pockets within the dense glowing threads. Occasionally, you pass a lone, wandering galaxy, a beautiful, slowly spinning spiral of light, containing billions of stars, completely isolated from the main clusters. But mostly, as you look out the window of your speeding ship, there is only endless emptiness, thin wisps of cold intergalactic gas, the invisible, pulling force of dark matter, and the faint, cold microwave glow of the cosmic microwave background radiation left over from the birth of time. After 10 million years of continuous travelling at the absolute speed of light, you finally encounter your very first major galaxy cluster. You see hundreds of massive elliptical and spiral galaxies spread across millions of light years, deeply embedded in a dense invisible cloud of gas, so hot, blindingly illuminating the dark spectrum. You fly directly through the centre of this cluster over the next few million years, watching massive galaxies slowly drift past your window, each one a staggering collection of hundreds of billions of burning stars, complex planetary systems, and perhaps entirely different, bizarre forms of life. Then you safely exit the cluster and enter more relatively empty space. Filaments of dark matter, acting like glowing cosmic highways, stretch endlessly between the next clusters. You follow these glowing filaments, watching the majestic, terrifying architecture of the cosmic web unfold all around you in the absolute dark. After 100 million years of travel, you have crossed less than a tenth of Quipu. Back on Earth, if the planet Earth even still physically exists, 100 million years have passed. The continental plates have violently shifted, broken apart, and collided again, forming entirely new supercontinents. Massive mountain ranges higher than the Himalayas have risen from the crust and entirely eroded away into fine dust blown into the oceans. Entire massive groups of species have evolved, utterly dominated the global ecosystem, and gone completely extinct, leaving only fossilized bones behind in the deep rock strata. And you, moving at the absolute maximum speed the universe allows, are still near the very beginning of your cosmic journey. You continue onward, pushing deeper into the massive structure, cluster after massive cluster, filament after glowing filament. The structure seems absolutely, terrifyingly endless, a perfect fractal of cosmic architecture. Each cluster you silently pass contains its own unique collection of galaxies, its own unique, violent patterns of boiling hot gas, and its own deep, violent history of formation, intense starbursts, and dark, destructive galactic mergers. After 500 million years of continuous, unbroken flight at light speed, you are about a third of the way across the Great Quipu. On Earth, if the entire planet was sterilized by a massive cosmic disaster, complex life might be evolving for the very first time all over again in the deep, warm oceans. Or perhaps life has gone completely extinct forever, leaving a barren, windswept rock orbiting a dying sun. 500 million years is enough deep time for almost absolutely anything to happen in the dark. Entire civilizations could easily rise to the stars, build galactic empires, and fall completely back to dust in that amount of time, leaving absolutely no trace of their existence. After 1 billion years of travel, you are finally approaching the far edge of Quipu. Our home star, the Sun, has changed noticeably. It is burning significantly brighter and much hotter than it was when you first left, burning rapidly through its remaining hydrogen fuel in its core, slowly swelling into a red giant. The oceans of Earth may be beginning to slowly boil and evaporate completely into space. The gentle, perfect, delicate conditions that allowed human life to flourish are permanently fading into ancient, forgotten memory. Finally, after 1.4 billion years of continuous travel at the absolute speed of light, you emerge from the far side of Quipu. Behind you lies the largest known structure in the universe, an architectural marvel of gravity containing billions of galaxies, trillions upon trillions of violently burning stars, and countless unseen silent worlds. Ahead of you lies whatever lies beyond. More cosmic web, more glowing, branching filaments, more terrifyingly empty spherical voids, more massive, unnamed structures waiting in the absolute dark to be discovered by whoever comes next. Zooming out one final time, pulling our fragile human perspective back to the absolute limit, we must deeply, carefully consider the observable universe as a whole. The observable universe is a massive, spherical bubble of reality centered directly on the observer on Earth, with a radius of about 46.5 billion light-years in every single direction. You might naturally, logically wonder how that physical size is even mathematically possible if the universe itself is only 13.8 billion years old. How can the physical radius be larger than the total age of the universe multiplied by the speed of light? The terrifying, deeply counterintuitive answer is that space itself has been aggressively, constantly expanding while the ancient light was travelling toward us. When we look through a powerful telescope at an incredibly distant galaxy whose ancient light took exactly 13 billion years to reach our curved mirrors, that galaxy has not just been sitting there patiently waiting. It has been physically moving away from us due to the relentless, unstoppable physical expansion of cosmic space the entire time the light was in transit. By now, in the exact present cosmic moment, that specific galaxy is much, much farther away than 13 billion light-years. It is currently located tens of billions of light-years away. Within this massive, mind-boggling observable sphere, there are approximately 2 trillion glowing galaxies. Every single galaxy contains billions or hundreds of billions of individual, burning stars. The total estimated number of stars in the observable universe is roughly around 200 billion trillion. That is a 2 followed by 23 zeros. It is a number that completely defies human comprehension or visualization. It is estimated by scientists that there are significantly more stars in the observable universe than there are grains of sand on every single beach, in every single desert, and at the bottom of every single ocean on planet Earth combined. And we now know, thanks to incredible missions like the Kepler Space Telescope, that most stars have complex, completely unique systems of planets orbiting them. The total number of planets in the observable universe is probably mathematically similar to, or even much larger than the total number of stars. That means there are quintillions of rocky terrestrial worlds, massive gas giants, frozen ice planets, and completely bizarre, alien worlds we cannot even begin to imagine, all floating silently in the dark. And here is the truly humbling, deeply terrifying thing about all of this. The observable universe is not the entire physical universe. The observable universe is strictly just the small part we can actually physically see. The small, localized by the finite speed of light and the finite age of the cosmos. And the finite age of the cosmos. It is a complete optical illusion of our specific location in space and time. There is almost certainly far more universe existing beyond our cosmic horizon, massive, truly infinite regions of space so incredibly far away that the light from their galaxies has simply not had enough time to reach us yet since the Big Bang originally occurred. And due to the violently accelerating expansion of space, driven by mysterious dark energy, light from those incredibly distant realms never, ever will reach us. The ancient light is fighting a completely uphill battle on a cosmic treadmill that is moving much faster than it can run. How much more universe is out there in the dark, beyond the invisible horizon? We truly, fundamentally, do not know. Some mathematical theories suggest the universe might be completely, physically infinite, stretching endlessly, violently, and forever in all possible directions without any physical boundary or edge. If the universe is truly infinite, then every single possible physical combination of matter must mathematically exist somewhere out there. Other mathematical theories suggest it might be finite but unbounded, like the curved, continuous surface of a sphere or a higher dimensional shape, meaning if you travelled far enough in single, straight direction, you would eventually, after trillions of years, return to exactly where you started. The honest, terrifying answer is that we have absolutely no way of ever verifying what lies beyond the absolute edge of our vision. This profound, unsettling fact means Quipu, as unbelievably large and massive as it is, might be considered entirely microscopic, a totally negligible speck of cosmic dust, compared to the true massive structures hidden deep beyond our cosmic horizon. The universe is continuously expanding, and that physical expansion is accelerating every single day. Dark energy, a phantom, invisible force we cannot see, taste, or measure directly, is aggressively pushing the very fabric of the universe apart at an ever-increasing, terrifying rate. Distant galaxies are rapidly receding from us as empty space literally expands, inflates, and stretches between us and them. The farther away a galaxy is from us, the faster it appears to be receding into the absolute dark. For galaxies that are currently far enough away, near the absolute edge of our observable bubble, the physical space between us and them is actually expanding significantly faster than light can travel through it. This does not violate Einstein's ultimate cosmic speed limit, because the distant galaxies themselves are not moving faster than light through their local space. They are essentially stationary in their local area of space, floating peacefully. But the empty space itself between the galaxies is expanding so rapidly that the vast distance between us grows much faster than light could ever hope to traverse it. This has dark, profound, and deeply melancholy implications for the deep, far future of massive structures like Quipu. As the universe continues to relentlessly expand forever, the slow-building gravitational growth of cosmic structure will inevitably slow down and completely, permanently stop. Dark energy will eventually absolutely win its long, slow, grinding battle against the pulling force of gravity. Massive galaxy clusters that have not fully merged yet will never merge. They will be aggressively pulled apart before they can ever touch. Glowing filaments will stretch, snap, and completely stop growing. The entire cosmic web, the beautiful, intricate structure we proudly observe today, will eventually completely freeze into its final dying configuration. In the far, deep future, perhaps tens of billions or hundreds of billions of years from now, Quipu will be totally, completely isolated from absolutely everything else in existence. The glowing connections and hot gas bridges between its massive clusters may thin out or completely break apart due to the violent stretching of space. The structure will persist for a long time, but it will be surrounded by an ever-expanding, terrifyingly cold void as the rest of the universe silently, permanently recedes far beyond our technological ability to observe. Future civilizations, if they exist, looking up at the sky hundreds of billions of years from now, will see a completely dark, empty universe, totally unaware that a massive, beautiful cosmic web ever existed in the past. We are nearing the end of our dark cosmic journey tonight. If this voyage across billions of light years has expanded your perspective on life, time, and reality, please subscribe. 2. This is Space, and leave a comment to help our community grow and reach more curious minds. We must consider the ancient burning stars we can currently see with our naked eyes, and what their ancient travelling light tells us about distance and deep time. When you look up at the night sky, you are not seeing stars exactly as they are right now in the absolute present moment. You are seeing a ghost. You are seeing light that has travelled for years, centuries, or even millennia to finally reach your sensitive biological eyes. Distance and time become completely, physically inseparable in the field of astrophysics. You cannot separate where something physically is from when you are seeing it. Sirius, the absolute brightest star in our night sky, is 8.6 light-years away. When you look at the brilliant, piercing light of Sirius tonight, you are seeing light that left that specific star 8.6 years ago. If you are a young adult, you are seeing Sirius exactly as it looked when you were just a small child. Vega is another brilliant, bright star, located about 25 light-years away. If you look at Vega tonight, you might be seeing light that left that violently burning star the exact very year you were born. Your entire human life has happened while that single beam of light was crossing the dark, empty void to reach Earth. Betelgeuse, the massive, angry, pulsating red supergiant in the constellation Orion, is about 550 light-years away. The reddish, flickering light you see from Betelgeuse tonight started its long, silent journey toward Earth in the year 1474 during the absolute height of the Italian Renaissance. The modern world as we know it, with computers, global electricity grids, and spaceflight, did not exist yet. Betelgeuse is particularly fascinating because it is a massive, completely unstable star nearing the violent, catastrophic end of its short life. At some point, the core of Betelgeuse will completely collapse, and the entire star will explode as a massive, catastrophic supernova. When it does finally explode, it will briefly shine as bright as the full moon in our sky, casting dark shadows at night, and remaining visible even during the bright sunny day. But here is the terrifying, mind-bending thing about the speed of light. Betelgeuse might have already exploded. The violent, cataclysmic explosion might have happened centuries ago in the dark, tearing the massive star apart and sending a violent shock wave through its local space. But we would absolutely not know yet. The blinding, deadly light from that catastrophic explosion would still be travelling silently toward us through the vacuum of space right now, taking 550 years to make the long, inevitable journey to our eyes. Every single star you see in the night sky is a literal, physical window into the deep, ancient past. You are absolutely not seeing the universe as it currently is. you are seeing the universe exactly as it was. But what happens when we finally catch one of these incredibly violent events the exact very moment its ancient, travelling light reaches our modern telescopes? Supernovae are full of deep, dark mystery. Even now, with all our advanced technology, we still do not fully understand what actually physically makes them explode. Part of the exact reason is incredibly simple. They are almost entirely impossible to accurately predict. We know precisely which massive, bloated stars are destined to die this violent, catastrophic way, but we have absolutely no way of knowing exactly when that catastrophic moment will finally come. It could be tomorrow, or it could be 1,000,000 years from now. Most of what we currently know comes from studying their ghostly, expanding aftermaths, from glowing, twisted remnants drifting in empty space, studied hundreds or even thousands of years after the explosion itself, or from incredibly rare moments of pure cosmic luck when we just happened to be looking at the right place at the exactly right time. But recently, something fundamentally changed in our scientific understanding of stellar death. For the absolute first time in human history, we did not just stumble upon a dead, cooling supernova. We caught one exactly as it was happening, just mere hours after it first began. It was one of the earliest, most pristine detections ever recorded by human instruments. And what we scientifically saw was something no one had ever seen before in the history of astronomy. We clearly saw the true physical, geometric shape of the explosion. It may not sound like much at first to a casual observer, but this single, precise detail could finally unlock exactly how stars truly die and definitively answer questions that have remained unsolved for centuries. What actually drives the immense power of a supernova? How does a completely collapsing, dying core suddenly reverse its momentum into a violently outward explosion? And why do some massive stars fail completely, collapsing into absolute silent darkness without a single flash of light, becoming black holes instantly? On the dark night of April 10th, 2024, the Atlas Automated Survey was quietly, methodically scanning the cold, silent cosmos. It was just another completely routine sweep across the vast night sky. 4 massive wide-field telescopes spread perfectly across the planet in South Africa, Chile and Hawaii were working perfectly together, continuously capturing the entire night sky every 48 hours, revisiting each designated region again and again, patiently, relentlessly watching for absolutely anything that changed in the dark. This constant, unblinking global surveillance means even the absolute smallest flicker of new light does not go unnoticed. And at exactly 3:21 in the early morning, something did violently change. A single, tiny point of light, barely visible to instruments before, had begun to brighten incredibly rapidly and steadily. Over just a few short hours, in less than 6 hours total, it had transformed from almost absolutely nothing into something completely impossible to ignore. The automated detection system reacted instantly. Urgent alerts were triggered in the dark, pinging servers. Digital signals spread rapidly across the global astronomy network, waking tired researchers around the entire world. Within mere minutes, telescopes everywhere began turning their massive, heavy mirrors toward the exact same specific point in deep space, located nearly 24 million light-years away, deep inside a distant, dusty spiral galaxy. A massive, dying star had just reached the violent, catastrophic end of its long life, and the Atlas survey had caught it in the absolute act of dying. It was identified as a Type II supernova, detected almost at the exact, precise moment it began to tear itself apart. For the brilliant, dedicated team watching the raw data come streaming in, this was not just another routine detection. This was an incredibly rare window, a once-in-a-lifetime chance to see something no one had ever truly seen before. Not the dusty aftermath, not the cooling, expanding debris, but the violent, pure explosion itself, exactly as it unfolded in real time. But that incredible, unprecedented opportunity came with a brutal, terrifying scientific limitation. The earliest, most pristine phase of a supernova, known precisely as the breakout, only lasts for a matter of a few short hours. After that tiny window permanently closes, absolutely everything changes. The rapidly expanding, superheated stellar debris aggressively collides with surrounding cold gas and dust, completely distorting the original physical shape of the explosion entirely beyond recognition. The original pure structure, the pure physical signature of the chaotic core collapse, the one single thing scientists needed most to understand stellar death, would vanish forever into messy, chaotic turbulence. So there was absolutely no time to wait. While most of the normal world slept peacefully, a dedicated team of brilliant researchers worked frantically, exhaustingly through the dark night, racing desperately against the cosmic clock to secure immediate access to one of the most incredibly powerful telescopes on planet Earth. Their desperate ultimate target was the Very Large Telescope located high in the dry, freezing mountains of Chile. If they truly wanted to capture the exact geometric shape of the raw explosion, they had to begin observing it immediately. Minutes mattered. Delays meant losing everything to the expanding chaos. Finally, administrative approval came through. The massive, building-sized telescope pivoted smoothly in the dark, and across the entire planet, in the absolute silence of the mountain night, one of the most powerful instruments ever built by human hands locked its gaze onto a dying star 24 million light-years away. This was the absolute moment of truth. Had they arrived in time, or were they already far too late? Then, the pure light data began to arrive on their screens, clean, completely undistorted, and exactly what they desperately needed to see. By the absolute narrowest of margins, they had captured something truly extraordinary and historic. They had perfectly captured the true geometry of a supernova frozen perfectly in its earliest, most violent moments. For the absolute first time, humanity was not just observing the messy aftermath of a stellar explosion. We were witnessing its violent, incredible birth, and beginning to finally understand exactly how the universe creates its most violent events. If you are deeply captivated by these cosmic mysteries and want to help us unravel more of them, please take a moment to carefully subscribe to. This is space, and leave a thoughtful comment below. Your engagement fuels our continuing journey into the dark unknown. Supernovae come in several different physical forms, but here we must focus intensely on Type 2, the kind violently triggered by the complete collapse of a massively heavy star. Over decades, dedicated scientists have combined complex mathematical theory, deep observation, and massive supercomputer simulation to carefully build a theoretical model of exactly how these massive stars die. It is not perfect, but it is the absolute best map we currently have of one of the most incredibly violent processes in the entire universe. At the burning, pressurized heart of every single star, a quiet, desperate, and completely unrelenting battle is always taking place. Gravity relentlessly pulls absolutely everything inward, constantly trying to crush the star into a single point, while nuclear fusion pushes violently outward with incredible, explosive force. As long as these two massive, opposing forces remain perfectly mathematically balanced, the star survives, stable, round, and unchanging. Fusion works by slowly combining lighter atomic elements into heavier ones inside the core, releasing immense, blinding energy in the process. This released energy creates a thermal pressure strong enough to perfectly resist the gravity of the star and hold it together in a near-perfect glowing sphere. Over millions to billions of years, the deep core slowly, inevitably transforms. Hydrogen fuses and becomes helium. Helium becomes carbon. Then oxygen, neon, magnesium, and finally silicon. Each step bringing the star closer and closer to its final deadly, unavoidable stage. And then it creates iron. This is exactly where everything fundamentally, catastrophically changes, because the element iron is completely different. Fusing iron does absolutely not release energy. It aggressively, hungrily consumes it from its surroundings. At this exact point, the nuclear engine inside the core of the star begins to catastrophically fail. The outward thermal pressure that once successfully held gravity back starts to critically weaken. And for the very first time in its incredibly long life, gravity begins to finally win the ancient war. What happens next is not slow or gradual. It is sudden, violent, and completely catastrophic. It is a complete collapse that unfolds in less than a single fraction of a second, setting the dark stage for one of the most powerful explosions in the universe. Eventually, the entire core becomes almost entirely made of cold, dead iron. It is an absolute dead end. No more fusion, no more energy output. The massive star has completely run out of nuclear fuel, and its internal engine shuts down forever. The outward pressure that once held gravity back completely disappears, and in an absolute, terrifying instant, the massive core begins to collapse completely inward on itself. This collapse is unimaginably, terrifyingly fast. The outer layers of the core accelerate downward to nearly 43,000 miles per second, which is almost exactly a quarter of the speed of light. At these extreme, terrifying physical conditions, matter itself begins to completely break down. Protons and electrons are violently, physically crushed together, combining and forming incredibly dense neutrons. At the exact same time, an enormous, invisible, ghostly flood of neutrinos is violently released, carrying away vast, unimaginable amounts of thermal energy from the rapidly collapsing core. The collapsing outer material violently slams into this newly formed, incredibly dense, solid neutron core, and, physically, violently rebounds off it. This aggressive, massive physical rebound creates a powerful, completely unstoppable shock wave that begins racing outward through the star. A brief, violent physical reversal, known as the core bounce. But the shock wave does not easily escape. Within mere milliseconds, it usually physically stalls just a few hundred miles from the center, rapidly losing its forward energy as it aggressively tears apart heavy atomic nuclei and struggles desperately to push through the incredibly dense, heavy stellar material, constantly falling inward. And this is the absolute critical, defining moment, the exact physical point where absolutely everything is decided. If the shock wave fails to recover its momentum, the collapse simply silently continues. Matter keeps falling inward forever until the entire star permanently, completely disappears into a singularity, forming a dark black hole. There is no explosion, no brilliant flash of light, just absolute, terrifying silence. It is a failed supernova, but sometimes something mysterious and violent changes. Energy is somehow magically, violently fed back into the dying shockwave. Boiling neutrinos, twisting magnetic fields, powerful jets, or something we still do not fully understand provides a sudden, massive boost of energy. The stalled wave comes roaring violently back to life, and the massive implosion violently, catastrophically turns into an outward cosmic explosion. Exactly how this physically happens remains one of the greatest unsolved problems in all of theoretical astrophysics, and that is exactly why catching this specific event matters so incredibly much, because it gives us a rare, fleeting, pristine glimpse into a violent process we still cannot fully explain. Once revived, the massive shock wave begins its unstoppable, violent journey outward, violently tearing through thousands of miles of incredibly dense stellar material. Hours later, it finally explosively breaks through the outer surface of the dead star. This is the exact moment of breakout. In that terrifying, explosive instant, the dead star releases a sudden, brilliant flash of completely unimaginable energy. Blinding light floods out into empty, cold space. The outer layers rapidly heat to tens of thousands of degrees, glowing incredibly intensely as the explosion begins to completely reveal itself to the surrounding universe. This is the absolute very first moment a supernova becomes visible in the dark. Its brightness rises rapidly and steadily over the following days, building slowly toward its absolute blinding peak. And that initial, exact rise, that very first tiny signal of brilliant light, is exactly what the automated Atlas survey captured in the early morning hours of April 11th. Catching it this early was a massive, unprecedented scientific breakthrough. But mere physical detection was only the beginning. What came next was far more important. It was a desperate, panicked race to observe the physical explosion before its original geometric structure was permanently lost forever to chaos. This was not just about seeing a bright, distant supernova. It was about capturing its true, exact physical shape before time completely erased the fragile evidence. They were not just trying to observe the explosion, they were hunting for a hidden, deeply coded signature inside its light, something incredibly subtle that only a very specific advanced instrument could reveal. Mounted heavily on the Very Large Telescope is a highly advanced, complex instrument called Force 2. It is the absolute only instrument of its kind in the entire southern hemisphere of the planet. It is designed not just to observe incoming light, but to intricately decode it. Specifically, it carefully, precisely measures polarization, the exact physical orientation of light waves as they violently travel through the vacuum of space. Normally, light from a star vibrates in every possible physical direction, chaotic, messy, and random. This is unpolarized light. But under certain specific, violent conditions, light becomes highly organized, its waves aligning perfectly into a single, exact direction. This is highly polarized light. You have seen this physical effect before on Earth. Sunlight reflecting off the flat surface of water creates a blinding glare, and that exact glare disappears completely when you wear specially polarized sunglasses. But here, in deep, empty space, polarization reveals something far more powerful. It reveals the exact physical geometric shape of an exploding, dying star. If the explosion were perfectly, mathematically spherical, the intense light would scatter evenly in all possible directions, leaving absolutely no polarization and no readable pattern to find. But if the violent, catastrophic explosion is physically distorted, stretched aggressively along a specific axis, the light carries that precise physical imprint, a hidden, complex pattern deeply encoded within it. And that is exactly what the Force 2 instrument was designed to patiently, carefully detect. As the ancient, intense light enters the massive instrument, it passes entirely through a rapidly rotating crystal, allowing scientists to analyze the specific polarization from multiple different physical angles, then completely through a special prism that perfectly splits the beam into two separate, distinct paths, each representing a completely different polarization direction. Each beam is carefully, exactly spread into its full color spectrum, creating two side-by-side visual signals. By comparing them mathematically, scientists can reconstruct the exact polarization pattern and finally completely reveal the true physical geometric shape of the massive explosion. For over 50 long years, this has been the absolute missing piece of the puzzle, a direct, physical clue to what actually truly drives a supernova. Two main, opposing scientific ideas had emerged over the decades. The first points entirely to the invisible, ghostly neutrinos. During the violent core collapse, an enormous silent flood of neutrinos escapes the dense core. Most pass straight through dense physical matter as if it were not even there. But in the extreme terrifying density, just directly above the newly formed neutron core, a tiny, crucial fraction gets trapped, depositing immense heat energy and violently boiling the material from below. This creates violent, chaotic boiling convection that can successfully, powerfully revive the stalled shock wave. If enough thermal energy violently builds up, the entire star explodes. But there is a major glaring problem with this theory. These specific physical processes are inherently deeply chaotic and completely uneven. Modern three-dimensional supercomputer simulations show clearly that neutrino-driven explosions should be incredibly messy, highly asymmetric, and completely irregular. And yet, that is not always what we physically actually observe in the universe. We have absolutely seen evidence of asymmetry before. The Cassiopeia A supernova remnant, for example, shows a highly uneven, chaotic distribution of radioactive elements like titanium-44 and nickel-56, which are the exact chemical fingerprints of an explosion that was never perfectly balanced from the absolute start. But there is another competing, entirely different idea, one that tells a very different, even more violently organized story. In this theoretical magnetic model, the completely collapsing core does not just form a stationary, quiet neutron star. It begins to spin violently, rotating faster and incredibly faster. Surrounding it, a dense, swirling disk of infalling stellar matter quickly forms, aggressively feeding the intense rotation. Magnetic fields deeply, physically trapped in this system become violently, chaotically twisted and massively amplified, wound tighter and tighter like a coiled, deadly cosmic spring. Eventually, that unimaginable, built-up energy has to absolutely go somewhere. It is violently, explosively released as two powerful, incredibly intense jets blasting out exactly from the magnetic poles of the star along its exact rotation axis, acting like precise cosmic blowtorches, completely cutting through the dense stellar envelope. These twin, powerful jets do not just completely escape into empty space. They physically shape the explosion itself. Instead of expanding evenly in a perfect sphere, the massive blast stretches aggressively along a single straight axis, forming a highly elongated structure, something looking much closer to a cosmic football or a giant olive. So which violent, physical picture is scientifically correct? Is it a chaotic, totally asymmetric explosion driven entirely by boiling neutrinos, or a highly organized, perfectly axis-aligned blast completely powered by twisting magnetic jets? This is the exact fundamental question scientists have been desperately asking for decades. And now, thanks entirely to the Rapid Atlas survey, for the very first time, we had a real, tangible chance to finally answer it. This is exactly what the precise polarization data finally revealed. There was a clear, entirely undeniable axis of perfect symmetry. It was a completely elongated shape, it was not chaotic. It was highly, beautifully structured. It was a true prolate ellipsoid, a massive, glowing cosmic football, completely frozen in its earliest, most incredibly violent moment. For a brief, absolutely triumphant moment, it seemed like we finally had the absolute final answer. The magnetic jets were real. The jet model was completely, undeniably correct. After decades of deep, frustrating uncertainty, the cosmic mystery appeared to be completely solved. But the deeper the brilliant scientists looked at the raw numbers, the more the absolute certainty began to fall apart. Because these highly theoretical models, as incredibly convincing as they heavily seem, are built entirely on supercomputer simulations. And simulations do not always survive direct contact with chaotic physical reality. The neutrino model constantly, deeply struggles to produce simulated explosions that are actually strong enough to match physical reality. Even under the absolute most ideal conditions, the simulations fall dramatically, constantly short of real observations, strongly suggesting neutrino heating alone may simply definitely not be enough. But the jet model has its own massive, glaring problem. In simplified, basic two-dimensional computer simulations, the jets work perfectly and cleanly. But in full, incredibly complex three-dimensional reality, something completely unexpected and chaotic happens. Even a tiny physical instability, something as small as a 1% physical wobble in the rotating core, can catastrophically destabilize the entire powerful jet system completely. In full three-dimensional reality, the powerful, intense jets do not stay perfectly stable. They violently twist, they aggressively kink, they begin spiraling wildly and chaotically around the rotation axis, much like water spraying chaotically from a completely loose, unheld fire hose. Instead of punching cleanly and perfectly through the star, they create tangled, highly misshapen lobes of highly magnetized material that drift outward in a complete mess. In those complex, realistic simulations, the massive explosion never actually, physically happens. There simply is not enough focused, organized energy to violently break the star apart. And yet, Supernova 2024 GGI clearly, undeniably, exploded. We saw the blinding flash of light, which fundamentally, inescapably means something major is completely missing from our understanding of physics. Either our highly theoretical models are completely incomplete, or we have totally misunderstood the core process entirely. But what if the chaotic, messy instability itself is the actual hidden key? What if the physical wobble, the twisting chaos, is not a fatal flaw in the simulation code, but a necessary fundamental feature of physical reality? If the intense jets do not remain perfectly steady, they cannot carve a clean, perfect path completely out of the star. Instead, they are violently, abruptly forced to dump absolutely all of their immense kinetic energy deep inside the star, roughly 600 miles from the deeply collapsing core. Their massive, incredibly violent shock waves build up incredibly rapidly, forming hot, incredibly highly pressurized bubbles that aggressively merge and violently expand, powerfully pushing the massive star apart completely from the inside out. The jets themselves are chaotic and twisting, but the resulting massive explosion that finally emerges from the surface can still somehow appear highly organized, symmetric along a single straight axis, looking exactly like Supernova 2024 GGI. So where does this exactly leave our fundamental understanding of the universe? We now know for an absolute proven fact that supernova explosions can have clear, elongated axial symmetry. But how that massive glowing structure actually forms, whether from jittering, unstable jets, extreme magnetic rotation, or something else entirely completely unknown to physics, remains deeply unknown. Even the true, exact role of ghostly neutrinos in events exactly like this is still deeply uncertain. It also naturally raises even deeper, more profoundly troubling questions. Why do some explosions look entirely, violently chaotic, like the sprawling remnants of Cassiopeia A, while others appear highly mathematically structured and perfectly elongated? What truly determines the final violent outcome? The honest, humbling truth is, we still do not fully know. And without significantly more raw, incredibly early data, we simply cannot definitively know right now. Supernova 2024 GGI is one of the very few events we have ever successfully captured this incredibly early and in this incredible, revealing level of detail. But that massive limitation is about to completely, forever change. New, incredibly powerful, wide-field sky surveys are fundamentally, completely transforming exactly how we observe the dark universe. Instead of patiently, blindly waiting, we are now aggressively, continuously watching. New, massive, automated observatories are constantly scanning the entire sky, night after night, searching for absolutely anything that was not there the night before. The very exact moment a new, tiny point of light appears, automated systems violently react instantly, triggering incredibly rapid follow-up observations within hours or even mere minutes. With this completely new, highly advanced generation of instruments, scientists fully expect to catch countless supernovae within mere hours of their initial explosion, maybe even much sooner. And with enough of these explosive, recorded events, the deep, hidden patterns will finally begin to clearly emerge. Supernova 2024 GGI showed us something profoundly, deeply humbling. Our scientific models are absolutely not complete, but for the very first time in history, we are finally close enough to carefully, precisely watch these incredibly violent events, exactly as they physically unfold in the dark, and piece together completely how massive stars truly die. And maybe, just maybe, the exact next violent explosion we successfully catch will not just answer our old questions, it will completely, fundamentally rewrite them. This brings us to the haunting, incredibly inevitable question of what these massive cosmic structures and violent explosions mean for the possibility of biological life existing elsewhere in the infinite dark. Given the vast, completely incomprehensible number of stars and planets, given that the physical universe is 13.8 billion years old and has had plenty of deep time to cook up the complex chemical ingredients for biology, it seems incredibly, highly statistically likely that life should absolutely exist elsewhere. The entire universe is composed of the exact same chemical elements everywhere. Carbon, oxygen, and hydrogen are completely abundant, and yet, we have never, ever detected any clear, undeniable signs of alien civilizations. We have heard absolutely no organized radio signals. We have seen absolutely no massive, unnatural laser pulses piercing the dark. We have observed absolutely no alien megastructures blocking the light of distant burning stars. Absolutely nothing. The terrifying, massive universe appears to be completely, utterly silent. This is the absolute core of the Fermi paradox. If the universe is so vast, where is absolutely everybody? The vast, unfathomable distances measured in light years might be the dark, profoundly depressing answer to this absolute silence. The physical distances between individual stars are so completely enormous that they present almost insurmountable physical barriers to any form of communication and travel. Our own human radio signals, television broadcasts, and military radar pings have been quietly leaking out into deep space for about a century now. They have reached all stars within a sphere about. That sounds like a large area, but the Milky Way galaxy alone is 100,000 light years across. Our tiny sphere of noise is a microscopic dot in the vast galaxy. Even if there is a highly advanced, peaceful, technological civilization living perfectly on a lonely, beautiful blue planet deep within the massive clusters of Quipu, even if they have been aggressively, loudly broadcasting powerful radio signals into the dark for millions of years, desperately hoping someone will listen, those incredibly weak signals would take hundreds of millions of years to successfully reach our delicate antennas. And if we miraculously heard them and sent a friendly response, our response would take hundreds of millions of years to reach them. By the time the returning message arrived, the specific civilization that sent the original signal might have been totally dead and buried under dust for entire eons. Meaningful, two-way communication across these terrifying, vast cosmic distances might simply be strictly governed by the absolute laws of physics, to be forever impossible. Each intelligent civilization naturally develops entirely alone on its own isolated rock, asks its profound, philosophical questions entirely alone, builds its grand monuments completely alone, and eventually dies alone in the cold dark, never absolutely knowing for sure if anyone else was ever out there sharing the empty universe with them. Or perhaps there is a great filter, a terrifying evolutionary hurdle that destroys almost all life before it can truly spread, keeping the universe silent. There is something profoundly melancholy, deeply, tragically sad about this cold physical reality, but it also profoundly means every single fragile civilization that does miraculously manage to arise from the cosmic dust is incredibly, unbelievably precious. If we are truly entirely isolated by vast distance, then what we carefully do here on this tiny, fragile blue marble matters immensely. We are deeply, fundamentally, physically connected to this massive cosmic web. The heavy atoms currently in your body, the complex carbon in your living cells, the oxygen you deeply breathe, the nitrogen carefully folded in your DNA, and the heavy iron actively pumping through your red blood, were completely not present at the beginning of the universe. The Big Bang only created simple hydrogens and helium. All the heavier elements were violently, incredibly forged inside the burning, pressurized cores of ancient, massive stars and spread violently, aggressively through space when those massive stars died in catastrophic supernova explosions billions of years ago. The scattered matter slowly coalesced into dark clouds, which formed our spinning solar system, which eventually miraculously formed you. You are literally, completely, scientifically made of ancient stardust. You are a way for the universe to know itself. Quipu is 1.4 billion light-years across. It contains 68 massive, violently interacting galaxy clusters, trillions upon trillions of violently burning stars, and countless unseen, completely silent worlds drifting forever in the dark. It took billions of years of patient, unyielding gravity to form in the dark, and will persist for billions more before slowly fading away into nothingness. And you, a relatively small, highly complex, entirely temporary arrangement of conscious atoms walking quietly around on the surface of a tiny rock, can actually comprehend it. The universe is a vast, completely empty, truly terrifying place with tiny, warm islands of light, permanently separated by enormous, cold oceans of absolute darkness. And yet those isolated, glowing islands are deeply physically connected by ancient light, travelling across the void, connected by the invisible threads of absolute gravity, and deeply connected by a shared deep history tracing perfectly back to the absolute beginning of time itself. The entire universe is physically looking at itself directly through your conscious, biological eyes. Every single time you gaze up at the night sky, the cosmos is desperately trying to finally understand itself. Thank you for taking this incredibly long, terrifying, and endlessly beautiful journey into the dark with me tonight. Sleep well, keep looking up at the sky, and never ever stop completely wondering about the vast, terrifying, and endlessly beautiful universe we call our permanent, only home.